Hi everyone, this video is intended as an example of the engineering design process. In science, we say that science is a body of knowledge. We also say that science is the pursuit of knowledge. We call that the scientific method. And we say that science can be used to solve real-world problems. When we're trying to solve real-world problems, we use something called the engineering design process. We use the engineering design process when we are presented with a problem that needs solving. We identify constraints surrounding the problem. We brainstorm out possible solutions to the problem. We do research around the problem. We design solutions to the problem. We build prototypes, little models, mock-ups of what the solution might be. And then we test the prototypes to see if they're any good. We evaluate the prototypes. We redesign. It's an ongoing cyclic process that moves us towards a solution that will satisfy the problem. This video is intended as an example of the engineering design process in practice. Sometimes in the classroom, students will say to us, when will I use this in my real life? Well, this video is an example of how I used the engineering design process in my real life to solve a real problem in my backyard. The problem that I was presented with in my backyard was that my wife and I had bought a chicken coop online. We'd constructed the chicken coop, we'd painted the chicken coop, and we became aware that the chicken coop had some limitations. First of all, when it was exposed to direct sun, it became incredibly hot inside the chicken coop. Secondly, we noticed that materials that the chicken coop was made out of were really not the most robust materials, and they were probably going to expand and swell when exposed to rain. We thought to ourselves, this chicken coop is not going to last very long. We need to make a shelter for the chicken coop. This was our problem. How are we going to build a shelter around the outside of this chicken coop that's going to help the chicken coop to last a few more years than we expect that it would have without the shelter? Having identified the problem, we then had to figure out the constraints that our solution was going to have to be created within. We identified 5 constraints that our solution was going to have to be built within. The first constraint is we wanted to build a shelter, and that shelter had to be built around the existing coop. The second constraint is we didn't want the shelter around the coop to block access to any other parts of the garden. So that meant that we had to have a 1 meter gap between the coop and the back fence, and we had to have enough space around the coop and the shelter that a lawnmower could move all the way around it. The third constraint was that the shelter had to be built above the chicken coop, but it had to be built underneath an existing lily-pilly tree. We deliberately placed the coop underneath the lily-pilly tree to try and maximize shade in summer. So this shelter was going to increase that shade, but had to be built in such a way as to not damage the lily-pilly tree. The fourth constraint was that we had some leftover corrugated roofing metal from a previous shed refurbishment, and we wanted to incorporate that metal into our solution because we had the metal and we wanted to put it to use. The fifth and final constraint is that although we wanted to create shade over the coop, the front of the coop still had to have some good sun moving into the coop during the winter months. So we wanted the front of our shelter to not be sheet metal or corrugated sheet metal. We wanted the front of the coop to be covered in some sort of transparent corrugated material. So having defined the problem and identified the constraints around the problem, it was time to get creative. Initially, I started by brainstorming out ideas on paper, just sketching them out, having a chat with my wife, thinking about what we wanted to do. And as an idea started to gel into mind, we realized that we needed a little bit more information. So we went out and got the dimensions of the coop, and we started researching into materials that we were going to use. We knew that we were going to use pine, and we knew that pine needed to be treated so it could survive well out in the Australian outdoors. We found out that there were different types of treatment for pine, so we found out what those different types of treatment were for. Some treatments were for putting the pine into the ground, some treatments were for just having the pine out of doors, some treatments were for having the pine in water, which we didn't need at all. So we gathered all that information that we could. We did some research into typical frameworks used for shelters. We had a look around our local parks to see what was being done. And we settled in on a really basic design of a supporting beam with a center post and a couple of rafters to put the roof onto. We got information on the best screws to use, and we also looked up how to best use pre-mixed concrete. When we were doing our research, we looked online, we looked on YouTube, we went down to our local hardware store and spoke with people who were in the hardware business, and we spoke with friends who were in the trades, going anywhere we could to get information we needed for our engineering project. Finally, it was time to design. We'd identified the problem, we'd identified the constraints, we'd done some brainstorming, done some research, gathered all of this information, all of this knowledge, all of these ideas, and we started to design. I decided to use Tinkercad to design my solution. Tinkercad's a fantastic program online. It's got a paid and a free version. I was using the free version. Using Tinkercad, the first thing I did was I created a virtual model of the chicken coop. I measured up all the dimensions of the chicken coop and programmed them into my virtual model. Then I started building my structure, my shelter, around that virtual model. Here's my first design that I came up with for the chicken coop. As you can see, the supporting posts are pretty much level with the long sides of the chicken coop. You'll notice that the beam that the central post and the rafters are leaning on was much lower than what you'll see later on. It was quite low. And you can see the rafter angles that I was using. I took the design to my wife and we had a chat about what was going on in the design, and we talked about what was good and what was not good in the design. This process, going back to my wife, sometimes known as the client, and talking about what we liked and what we didn't like about the design, what we thought was working, what we thought was not working. In the engineering design process, that's called iteration. It's a cycle that goes on and on and on constantly throughout the engineering design process, where you're constantly reviewing and rethinking your planning as you go. After this conversation, after this dialogue with my client, sometimes known as my wife, we then came up with a final solution for the design, which you can see here. You'll notice in this final design, the shelter is wider, extending beyond the dimensions of the coop. And you'll notice that the supporting beam that the central post and the rafters are leaning on is higher, making for easier access into the coop, so less ducking for me. With the design selected, we started the process of prototyping. We were pretty much committed to the location of the supporting posts, so we concreted those into place. But as for the rest of the coop, we put it together using G-clamps. We didn't cut up the timbers, we just placed them in their rough locations of where they were going to be. This was called prototyping. Gave us a chance to see how the structure was going to look and to see how easy or how not easy it was going to be to put everything into position around the outside of the coop and also underneath the existing lily-pilly tree. During the prototyping process, we were able to adjust the angles of the rafters to see which angle we liked best. We were able to adjust the length that the rafters extended out beyond the supporting posts. That was a conversation we're having throughout the design process. How far do we want the roof to extend beyond the posts? The benefit of having it extend beyond the posts, and you will have seen this in some of my sketches and designs previously, the benefit of having the roof extend beyond the posts was that it would offer more shade and more shelter from rain. But the risk of having the roof or the rafters extend beyond the posts is that it would create a hazard for people walking past the coop. Corrugated sheet metal can be quite sharp. In the end, we decided to have the rafters and the roof stop at the posts rather than extending beyond the posts, because we thought that safety was more important than increasing the amount of shade and shelter from the rain. Another thing we did during the prototyping is that we placed sheets of cardboard onto the shelter where we were going to place the corrugated metal and the corrugated plastic, just to get a bit of a feeling for how the shade was going to fall onto the chicken coop. We monitored the shade during the day and had a bit of a feel of our hands. The difference, even with just cardboard, the difference for the temperatures that were happening inside of the coop when there was cardboard over the top of the shelter was dramatic. So we were pretty pleased with that idea. And it gave us a bit of a feeling for how high the roof was going to be above the coop and what the temperatures were going to be like. So then with everything we learned from the prototyping, we went back to our designs and finalized those and began the construction of the coop. It was during the construction phase of the engineering design process that I really saw the benefit of the research that I'd done previously. Seeking out advice from tradesmen, from friends, from people who work in hardware stores, seeking out advice online and from YouTube really came in handy during the construction phase. It helped me to slowly, steadily, and safely put together the chicken coop in such a way that hopefully it won't fall apart anytime soon. So that's my example of how the engineering design process was used by myself here at my place to solve a problem in my backyard. The engineering design process, from identifying the problem all the way through to finished product, is a process that everybody can use to solve problems in their real lives. It's a process which will be useful. It's something that you learn in school and then you can actually use in your real life later on. The rest of these images that you see now are the finished product of the chicken coop shelter. I hope this video was useful for you. Maybe there's a problem in your life, in your backyard, that you can use the engineering design process to solve.